welcome to another video. Right, what we're going to look at today, in this video is stepper motors, or a stepper motor. Right, if you remember in the last couple of videos, we looked at servos. They've got limited range of movement, whereas a stepper motor doesn't have them limitations. It can go round and round and round. Right, it's an open loop control device, if you like, which converts an electric pulse signal into angular displacement or linear displacement, so it can go round and round and round. Now, inside there's magnets, and those magnets on the case and the magnets in the middle, that's what gives it its movement. And in there's 2, 4, 6, 8 magnets, right? Electromagnets. Okay, so and when we put power through it, then magnets turn the motor which way we want it to go. The fastest you can put on it is 3 milliseconds, right? 3 milliseconds, because otherwise it won't work. Right, so shall we go over to this view and let's connect it up, shall we? So let me just make sure you can see this. Here's our stepper motor. Right, this is our stepper motor. I'll put a little bit of tape on it so you can see when we start using it and it goes round and round, we can look at it. Here's a connector. Don't know the name of this connector. Okay, I don't know the name of it. All I know, it's 5 pins. All right, it's 5 pins. So if we look on our board, because this is the only connector of this type, it's there, right? And it can only go one way. Right, the stepper motor does need 5 volts, and the 5 volts is at the bottom. So as you can see, the 5 volts lead is red, and it just plugs in here. Okay, just plugs in there. Now, what the stepper motor also has to use is a driver, right? A driver. And let's see, just trying to remember the number of the driver. I don't think it really matters, but the driver is just next to it here. All right, it's just next to it here. All right, now what we have to do, don't know what's happened here. Oh, for some reason my Raspberry Pi is booting. I don't know why. It's rebooting. Really don't know why. We'll have to give it a minute. But what we can do, we can go to here, and we have to turn on the stepper motor, which is number 1. And on the block it's 1, 2, 3, 4. Right, 1, 2, 3, 4. Okay, I just want to check something. Don't know why my Raspberry Pi rebooted. Default. Save. Okay. Let me just check that again. I don't know what happened there. I really don't know what happened there. Okay, so we go to our overhead view, and we'll start the coding. Yeah, I don't know what happened there. For some reason, my Raspberry Pi decided to reboot. Okay, let's open Thony. Okay, there we are. There's our Thony. It's quite a long program, this, so I won't go too fast, but I'll try to go as fast as I possibly can. Let's open our template. Okay, we'll do a file save as. I'm going to call mine stepper.py. Don't forget the extension. And there we go. And we changed to stepper. Okay, we need our import rpi.gpio as GPIO. We need our import time. Right. Just come down a little. Now we need our next attribute, which is our motor pins. Yeah, equals brackets on, and I believe 29, 31, 33, and so it's 29. Okay, 31, 33, comma, and 35. Brackets off. Yeah. Define our pins. Now what we need to do is define the power supply for clockwise and anti-clockwise. We'll do the counterclockwise first. Step CCW capitals with capital S step. Okay, equals space brackets 0 times 01, comma, space 0 times 02, comma, space 0 times 04, right, comma, space, and it's 0 times 08. All right, brackets off. That's the power supply for the order rotated anti-clockwise. Right. Now we need the CW step. Yeah. Is equals. Right. And it's the other way round. So it's brackets on. So it's 0 times 08. Yeah. Comma, space. 0 times 04. Comma, space. 0 times 02. Comma, space. 0 times 01. So that's the clockwise power distribution. Okay, power supply. Yeah. Good. So that's the 3 lines code there. Let's come to setup. We do not need global P. We do need GPIO.set mode to board using the physical pins. And then it's 4 pin in motor pins. Yeah. Colons. Space auto indent. Yeah. GPIO dot setup brackets on pin comma GPIO dot out. That's telling that all our pins are out. Okay, use a physical numbering system. Right, now then, here's a new one we haven't done before. So backspace to the beginning, def. Move 1, capital O, period, capital P. Yeah. Brackets on, direction. Brackets, ms, milliseconds. Right. Brackets off, colon, full colon, auto indent. 4 I in range. Yeah. Brackets on, and it's 0, comma 4 comma 1. Yeah, brackets off, colons, cycle for power supply order. Right, next one, 4, I in range. Right, okay, we need to change that. J in range. Right, J in range. This is for I in range. Glad I spotted that. Okay. Brackets on. And it's again 0, 4, 1. Brackets off. Assigned to each pin. Right. And then that's colons. Another indent. So we've done the 2 4s. If brackets on, direction is equals to 1, brackets off, colons. Okay, power supply order clockwise we're doing here. Clockwise. GPIO dot output brackets on motor pins. Now this is square brackets, okay? Square brackets I, square brackets off. Now my square brackets are on and off next to the P key. Comma. Brackets on twice. CCW, counterclockwise, step. Square brackets, J, square brackets off, equals 1. And then it's a greater than, I, brackets off, and GPIO dot high. What did I do? Great dot high, and GPIO dot low. Brackets off and close the first bracket. Right. So, yeah, we're moving on. Right. Now we've got the else power supply anti-clockwise. Now this time, the else, tab it across to under the if. Right, under this if. This, we can cut it. Okay? So else, GPIO dot output, brackets on, motor pins, capital P on the motor pins, if you've named it that. Okay, you've named it motor pins. Right, square brackets, I, square brackets off, comma, and it's, let's make sure I've got this right. Brackets on, and it's CW, yep, step, very similar to the line above, square brackets, J, square brackets off, space equals 1, greater than, I, brackets off, and again, and GPIO dot high or GPIO dot low. Brackets off and brackets off. Right, so let's come down. So we've done the clockwise power and we've done the anti-clockwise. So counterclockwise, yeah, and clockwise. Right, return. Return, backspace. We want to come under the else. Okay, so it's if brackets ms greater than 3. Remember I said that's the fastest it can go, 3 milliseconds, colons, okay, ms, sorry, not ma, ms equals 3. Yeah, and backspace. So that's making sure that, have I got that right? Yeah, less than, yeah. That's making sure it doesn't go over 3 milliseconds. Time.sleep. Okay, brackets on ms for milliseconds. Star 0.001 brackets off. Right, okay. Right, so that's the period. Then we got return, backspace, back to the beginning. We've got another define, motor, move steps. All right, move steps. Brackets on, direction, comma, ms for milliseconds, comma, steps. Brackets on, colons, enter. Right. Okay, looks okay, looks okay. For I, in range, brackets on, 0, 4, 1, brackets off, colons, GPIO, dot output, brackets on, motor pins, and we've got the old square brackets again, I, square brackets off, comma, GPIO dot low, brackets off. Function used, yeah, continuous rotation function. The parameter steps specifies the rotation cycles every 4 steps. Yeah, so that's the move steps, just making sure. Okay, now we need to stop. So back to the beginning, we need to stop the motor. Right, so DEF space motor stop. Right, brackets on, brackets off, colons. For I, in range, zero, 4, 1, brackets off, colons, a GPIO, yeah, dot output, brackets on, motor pins, square brackets, I, square brackets off, comma, GPIO dot low. Okay, brackets off. Right, so we're up to there. Now we come into our loop, our while loop. Well, true is always true. Let me just have a quick sip. Yeah, a bit of a long program this, bit of a long program. All right. So, return. Move steps, capital E on the S. And brackets 1, 3, 512. Brackets off. Move steps, rotating 360 degree clockwise. A total of 2,048 steps in a cycle. 512 cycles. Right? So that's that one. Then we do a time dot sleep. Brackets on, 0.5 of a second, half a second. Yeah. Then move steps. Right. Capital S. Brackets on, 0, 3, 512. Brackets off, rotating 360 degrees anti-clockwise. So we've got our clockwise and our anti-clockwise. Seeing that? .05. Okay. So we do that. Then we do another time dot sleep. Again, brackets on, 0.5, brackets off. At this point, I'm going to do a quick save. And we come to our GPIO.cleanup, release all the resources. Okay. And then we've got our destroy. Right. Long program. Right. Okay, long program. The only thing we can do, I suppose, is run it. Let's run it. See what we come up with. Right. Let's go line 29. I already can see it. Line 29. Dot output. Yeah. Okay. 37. Move steps. Move steps. Let's have a look. Move steps. Capital S. 1 3 5 1 2. Right. Stop this. 29. Move steps. Right. Let's try again. 38. Time.sleep. Okay. Stop that. We'll get it going. We'll get it going. Let's save it. And let's start the program. Stop the program. Let me clear all resources. And then start it again. Program is starting. Right. Okay. Let's go over. Only a few little mistakes here. I'm quite surprised. Quite surprised. Can you see it rotating? Let's get it where you can see it. Okay, so it goes round. Stops. Oh. And goes back. And there you go. And there you go. Great. That's great. Let me stop the program. So, that's how we control a stepper motor with the Raspberry Pi, the configuration. I am putting, slowly putting all these configurations that we've done. I'm copying them and putting on the Patreon page. So if you do want to come become a Patreon, you can get all the configurations off there. But until then, please like, subscribe, and I'll see you in the next video.